In this video, we're summarizing how you can reflect to find solutions. So first, here's an example of the cosine. So we are told that the cosine of x is equal to 0.3281. And so, of course, we take the inverse cosine of both sides of this equation. So the inverse cosine of the cosine of x is x. And the calculator will show that the inverse cosine of 0.3281 is 71 degrees. And once we have one angle, we can reflect to find the others. So first we draw a unit circle, and we estimate where 71 degrees is. It does not have to be very accurate. You really just need to make sure it's put in the correct quadrant. 71 degrees is about right there. So if this is 71, let's find the appropriate reflection to get the other solution. Well, the other angle has to have the same x coordinate, and so we're going to reflect across the x-axis. Why the x-axis? Because the cosine depends upon the x-coordinate. So with cosines, we reflect across the x-axis here, so I'm going to reflect this angle across that x-axis, and we end up with this one. Good. So if this is 71 degrees here, then the size of this angle must also be 71 degrees. And what we want is the size of this large angle here. Well, to get the size of this large angle, we could go all the way around, which would be 360, but then we'll back up that 71. So 360 minus 71, and that gives us 289. And so the other solution, x equals 71, is one solution, which the calculator gives us. The other solution comes when x is 289 degrees. Let's do it now for the sine and compare, see if there's any differences. So in this case, we're looking at the sine of theta is equal to 0.9854. So we'll take the inverse sine of both sides. The inverse sine of the sine of theta is theta. And the inverse sine of 0.9854 is 80 degrees when rounded to the nearest whole degree. Good. So the calculator gives us one value of theta. Let's do a reflection to find the other values of theta that make this happen. So we draw the unit circle, and we'll estimate where 80 degrees is. 80 degrees is perhaps right about there. We'll call this 80 degrees. And we're going to reflect this angle across the y-axis, because sines depend upon the values of y. So when we reflect this angle across the y-axis, we end up right there. And if this was 80, then that means that this one must also be 80. And therefore, the size of this larger angle that goes from the x-axis all the way to there, well, that must be the 180 that takes you all the way over. But then we'll back up 80, and so that's really 180 minus 80. And so the size of this larger angle is 100. Right? Because the 180 and then minus 80 gives us 100. So, for the cosine, we reflected across the x-axis. For the sine, we reflected the angle across the y-axis. And now let's do one where we take a look at a tangent. So here this is saying that the tangent of A is equal to 2. Well, we can take the inverse tangent of both sides. So the inverse tangent of the tangent of A is A. And the inverse tangent of 2, using the calculator and rounding to the nearest whole degree, comes out to be 63. Now, we can find other values that make that work by reflecting in the right way. So I'm going to draw in a unit circle again. Here we have a unit circle, and we'll estimate where 63 degrees is. 63 degrees is right about here. We'll call that 63 degrees. And in this case, for a tangent, we're not going to just reflect across the x or just reflect across the y. In fact, we reflect across both, because a tangent is a sine over a cosine. And when you reflect across the x-axis and the y-axis, what you're doing is you're reflecting right through the origin. So this angle reflected through the origin takes us over to here. And since this is 63, that means that this angle must be 63. And so the size of this large angle that goes from the x-axis to there, that must be the 180 plus 63 more. And 180 plus 63 tells us that the other value of A is going to be 243. That's what you get when you do the 180 and then plus 63 more. So we end up with 243 degrees. So as a quick summary, when we were dealing with the cosine, we reflected across the x-axis and then figured out the size of that other angle. For the sine, we reflected across the y-axis and then figured out the size of that larger angle. And for the tangent, we reflected straight through the origin and then figured out the size of that larger angle.